That's funny, Chloe. Okay, we are working on a review for the final. Uh, so that's just great. We're working on the review for the final. We'll do that both days. Today we're doing number 1 through number 26. Let's get going. Let's see. I want to pretty much build off of the exam itself. I might not be able to fit every problem in here, but I'd like to stay on this page. We'll see. Let me get a blotter page from underneath here. Okay. This practice test, we're going to do 1 through 26 today, and we will do the rest of it on Wednesday. There are 54 problems on this review, and 54 problems on your review at my math lab. The first one that you see on my math lab that is due on Friday, I believe, is the one that is part of your grade. You'll get a bonus point for that. Regular kind of thing. It factors into your grade. The other two you'll see are due July 4th. Well, we're not in class on July 4th, so those don't count toward your grade. Those are just if you feel like taking a practice exam beforehand. Even though this is 54 problems, your actual final will only be 40 problems. It'll be 40 problems and multiple choice. Okay, let's look at number 1. Solve the polynomial equation by factoring, and then using the zero product principle. There's nothing in there that's new or weird to you. We're used to doing that. I see there's an x I can factor out of each of those terms. So you start with the GCF of x. We end up with x squared minus 4x minus 12 there. So let's see what we can do with that. Let's factor that into x and x. The signs need to be different. I mean, we were doing this day 1. What multiplies to give you 12, whose difference is 4, that's 2 and 6. And then if we want it to be a minus, we want to put the minus on the 6 and the plus on the 2. So I've got a plus 2 and a minus 6. And then we're looking for what x's will fit here. X equals 0, x equals negative 2, and x equals positive 6. So 0, negative 2, and positive 6 are the 3 answers there. You were expecting 3 answers because it's an x cubed. The exponent will tell you. Okay, solve the radical equation and then check all proposed solutions. When I go through and look at your scratch, and I will, and we'll talk about that as we go, when I look at your scratch, I expect to see work here. I expect to see work here. I will not count off if I don't see a check. I'm just not going to count off if I don't see a check on it. But when you've got a radical problem, that's one of the very few times that we have to check our answers. So let's first solve for the radical. You want to get it isolated. Move the 8 over. So we end up with the square root of 2x equals x minus 4. Now we need to square both sides. You need to get that radical gone. To get rid of a square root, you square it. If you square one side, you need to square the other. You will see that there are very few of these problems that are going to be challenging to you at this point. You've got the skills, and the questions that are being asked of you are not difficult questions. Traditionally, this final has been one of the better test grades for students. So this is not a killer final. You have to prepare for it, but it's not going to kill you. 0361 and 0362, those finals kill students. A student can expect to lower his average by 1 solid grade as a result of the final in those developmental classes. That's not the case in college algebra. So if you've gotten this far, you're good. Unsquaring and squaring cancel each other out, so we end up with 2x there. Squaring this, that's a binomial, x minus 4 times x minus 4 gives you this. I saw that most of you could handle that squaring of a binomial on the test, on the 4th test. Move this 2x over, minus 2x, and we get 0 equals x squared minus 10x plus 16. Factoring again, x and x. The signs need to be the same, and they need to be negatives. What two numbers multiply to give you 16 that add together to give you 10? That's 2 and 8. So we end up with x equals 2 and x equals 8. You have to check those answers. I'm going to have to move over and check. I'll check them up here. Let's check those answers. Let's check 2 first. So we put it in there. 2 times 2 plus 8 equals 2 plus 4. So we get the square root of 4 is a 2. 2 plus 8 is 10. 2 plus 4 is 6. That doesn't check. So 2 will not work as an answer. I'm going to cancel that one out. 8, if I try that, let's check 8. That would be 2 times 8 plus 8 equals 8 plus 4. 2 times 8 is 16, and the square root of 16 is 4. 4 plus 8 equals 8 plus 4, yes. So 8 is the only answer. So on the answers, the multiple choice, you'll see 2 and 8 offered to you. You'll see also 8 offered to you. Well, why are they taking the 2 out? I hope your brain says. And your brain says, oh, that's right, I got to check this one. So the only answer here is 8. It's the only one that works. Okay, I'm going to take this one off to, I'll do it up here. No, I'm going to take it off. So this is number 3. We've got x plus 3 raised to the 3/2 equals 216. You've got to get x by itself. So the first thing you got to do is get rid of that exponent. So I'm going to raise this entire problem to the reciprocal, 2/3. 3/2 times 2/3, that gives you a 1. So this is x plus 3 to the first power. So we get x plus 3. Whatever you've done to one side, you have to do to both sides. So we've got it raised to the 2/3. Let's see. 216 raised to the 2, ABC 3 will give you 36. That's not using your calculator. Sorry, that is using your calculator, not using your brain. I need to see this written 216 with the cube root and then raised to the second power. I'm going to be looking for that. You have to show me that you understand not how to push buttons in a calculator. And I required this on test 2 anyway, or test 3. I required that you show this. So this is not a new rule. You've got to put the cube root. The denominator is the index, remember. Denominator is the index. And then the number on top is what you will square the whole thing or whatever, raise it to that power. So the cube root of 216, let's see, let's do cube root. Remember, with your calculator, you've got to let it know you want cube root. So we've got cube root right there of 216 equals, that's a 6. So this is a 6, and 6 squared gives you 36. I know that takes you longer. The name of the game in this class is not how fast can you do these problems. The name of the game is, did you learn something in this class? So I need to see this piece or you will not get credit for it. You've got to show your work. You've got to show your work. You've got to show your work. -3, so x equals 33. So that's the answer that you get for this problem as you work it out. This is the same requirement for when you took the test, so there's no difference there. If you feel like using your calculator to say 216 raised to the 2/3 to get the answer so that you know if you're doing it right or not, I'm all for that. I'm all for that. I am all for you taking answers from the multiple choice and plugging them in and seeing which one works. I've told you many times, that's a great idea. You do that all day long, but that's not good enough. I want you to know what the correct answer is, but you have to be able to get it showing your work. Let's see, we are 11 right now. That's probably the most we're going to have. Let me take a break for just a second as we finish number 3. So number 3, the answer there is 33. And talk to you about the test. I gave you my subjective reasons why I graded the way I did in that long email I sent to you yesterday. This morning, I thought, well, wait a second, this is a math class. Let's look at the numbers. Let's see what the numbers tell us about test 4. So I did that. Let me do the FERPA thing here. And here is our tests over time. First test, second test, third test, fourth test. You can see, let me focus this again. See if that'll come in a little better for you. A little bit. 17 A's, 6 B's, C4, D4, F4. The average was 86. The average on the previous test was 87. The average on test 2 was 83. And the average on the first test was 89. So 86 falls in there completely. Look at the stats here. 17,6,444. Look at test 2. 17,6,434. 2 zeros. Whatever. 35 people took that test, 34 people took this one because one fewer D on test 2 than test 4. So this is completely in line as a group. As a group, you performed completely in line with the other tests. Let's look at individual, because then I went back to see, well, maybe I screwed over a couple students that I didn't really intend to screw over. Let's look at that. Here, before. What I did is I went and looked at everybody's grades, and I looked for people for whom test 4 was their lowest test grade. I found a couple of people who had like 1 point for it was 1 point lower as their lowest grade, like they had 80, 80, 80, 80, 79, that kind of thing, where this test was the lowest grade by 1 point. I can't get too butthurt about that. That's the same thing. Then I had 2 students who had all A's, but this was their lowest grade, like 101, 101, 102, 92. Again, that's a solid A. You can end up with an A in the class. Doing great. Keep doing it. All A's. Then there were these 5 students that I found. These are the only 5 students that I haven't just described for whom this is their lowest test grade. So first grade, first test, second test, third test, fourth test. Let's look at them individually. So for this student, look at the pattern, 74, 76, 67, 63. It goes down except for this one, which was our hardest test. And that's a normal pattern. When you start off without a great foundation, you lose ground a little bit each time. So that's a normal, I'm not worried about that person at all for 63. And it's certainly within range. I mean, it's just a pattern. Here's second person, 99, 87, 75, 72. So for this person, that was their lowest test 4 was their lowest test grade. But again, it's got that decreasing pattern, which is so normal in any class where you accumulate information little bit by little bit for it to go down. So 3 points, I can't get too worked up over that. This one I can get too worked up over. This is one of the 2 that maybe they've got an argument. 92, 96, 100, and then an 84. This person's going to end up with an A. There's almost nothing they can do at this point to not get an A. So I am not concerned about that, but I get it that person might look at that 84 and have a cow. So that's one person. This is what I described. These are all A's. That's an excellent grade. This person can't make that not happen. They're going to make an A. And I know if it were my grades, I'd be a little bit out of shape too if I had all hundreds and then a 92. But it's an A. And then this is the other one that is a little bit worrisome. 81, 84, 92, and then clunk, 73. So there are 2 people who, out of 35, who have an argument. And I don't know. I didn't have time this morning to go back through those 2 tests and see if there was a real argument. You know, if they did get screwed over in this whole you had to show work thing. However, I can go back to what I talked about in my email yesterday. I explained it to you a billion times. I don't know what else I could have done short of making you sign something that you understood that you had to show work and it had to be the way I was asking for it. So out of 35 people, I got 2 people with a complaint. This person has a 95 average. They're going to make an A in this class. This person has an 85 average. And if you look at those, you can say, well, 85 is a fair representation of those numbers, even if you count this one out. So I'm not worried about what happened. Everybody got grades that were in line except for those 2 that were in line with what they performed in this class. One other small piece of feedback that's sort of rude. If you have to make an A, a B, a C in this class, or you've taken it for the second or third time and you just have to pass it, April 30th is not the time to start worrying about that. You should have worried about that January 21st. Maxing out your homework, maxing out your time on, getting this review done each time. And the tests are not that different. Test 4, except for 2 people, I'm happy with those. So if you have further concerns about it, I don't want to do it in a group setting, but please email me or write me. Well, email me, or let's meet at BBCU and talk about your grade if you want to. But I think I'm good. The final will be similar. You have to prove that you know what you're doing on the final. Let's see, what's different about the final? You must show your work for every problem that has steps that can be shown. And just like last test, you if they've got specific directions about how to solve it, I want to see that. So read the directions. Following directions, my God, this is a college algebra course. You get college credit for this. I just filtered myself what I was going to say, and that's a good thing. I don't often filter myself. Let's see. I'm going to wait for Luce to get back in. Looks like, Luce, you're back in. I want to be sure to hear. Good, because I didn't want you to miss some of this. The only new thing that I would expect would be new for you on this test, instead of 25 problems, there are 40 problems. And if I'm going to look through and find your work, and I'm not going to die of old age in the meantime, you're going to have to number your problems. If you don't number your problems, I'm going to take 10 points off, and there is no conversation you can have with me that will change my mind on that. Oh, I'm sorry, I forgot. Oh, sorry. Too bad. You must number your problems. If you would like to put that at the top of your sheet of paper of your scratch, focus in on it clearly so I can see what you've written on your scratch before you start. Number your problems. You must number your problems. Yeah, many of you do, and I've never requested that before. 25 problems, I can handle that, but 40, no. And looking over, you remember this time I graded 12 or 13, something like that, and it took me some time. It was not the easiest thing I've ever done. So just number your problems. It is at Proctorio, it's in the initial instructions that you see before you start your test, but it's not in the instructions that you look at as you get going. Those are 2 different sets of instructions on this one. I'd have to start fresh. Proctorio is a pain. So it is in the initial instructions, and I'm telling you today, and I'll tell you on Wednesday, you must number your problems, or I'll take off 10 points. And then your scratch, oh my gosh, your scratch must support your answer. You cannot put x equals 2 and then on the problem choose answer B where x equals 7. I mean, come on. I had 2 of you arguing with me that I don't know what you were arguing with me. But if your scratch does not lead you, as I look down, and you get x equals 2, and you pick the answer that says x equals 7, you don't get credit for that problem. Come on. Okay. Get my panties unbunched here. Let's go to number 4. This isn't really a problem. This is just reminding you of all of the different kinds of graphs we have looked at. And pictures of those graphs are in the answers at the end of this review. So at the back where the answers are, you can see a quick tutorial on those. I want to tell you that there will be no graph problem in 2 dimensions, no XY graph where I will expect to see work. You don't have to show work on any XY graph problem. They can all be done pretty much in your head, and I'll show you as we go through this when we look at graph problems. Number 5, this is a piecewise function. This is how we did this one. We've got 2 different situations, when x is less than 2 and when x is greater than 2. So first thing I want to do is put that barrier up. There we go. There's our barrier. Stuff's going to happen over here that's different than happening here. The rule when x is less than 2, the left-hand side, is negative x plus 3. So let's see what's going to happen close to 2. 2 doesn't count here. I want to be sure I put a hollow circle there because 2 is not going to count. But it'll give me an idea of what happens as we get close to 2. I'm looking for other numbers that are less than 1. That's like, or sorry, they're less than 2. I'm looking for other numbers that are less than 2. That's 2, 1, and 0. So plug in negative 2 plus 3 is a 1. Negative 1 plus 3, negative 0 plus 3. So let me go graph those. Let's see. 2, 1, I'm remembering will not count. It says it's not equal to 2, so that's going to be hollow. And then 1, 2, and then 0, 3. So that goes flying off in that direction for the left-hand side. Let's see what happens with the other rule, where the x's are greater than or equal to 2. So I'm going to do 2, 3, and 4 there. I'm going to plug those in. 2 times 2 is 2, or sorry, 2 times 2 is 4. 4 minus 3 is 1. 3 times 2 is 6, minus 1 is 5. And 8 minus 3 is, look at that somewhere. 6 minus 3 is 3. How about that? And then 5. Okay, let's look at what's happening on that side. 2, 1 is filled in. That's an or equal to. So in this case, we can go ahead and fill that sucker in. Then 3, 3, 1, 2, 3, 1, 2, 3. And then 4, 5, something like that. Okay, so that's what that'll look like. A V, you know, this will be filled in. Okay, let's look at number 6. Find the domain. The domain always is just talking about the denominator. You're allowed to put in any number in the world unless it's going to zero out the denominator. So we want to see where that happens. X cubed minus 36x cannot equal 0. Pull out an x. Cannot equal 0. I expect to see this. Oh, wait, back up, back up, back up. You will not have an actual piecewise function to draw. Thank you. Am I back yet? I'm not back yet. Ah, now I'm back.
Yes, I see you now.
Great. Oh, well, Chloe, I'm glad you could hear me, but I know I had those little red marks. Oh, now I got red marks again. Now I'm gone. Okay, so just keep telling me, Rebecca, if I fade out. My guess is not just you. Okay, so back up to this number 5. You will not have to create a piecewise function if I'm remembering correctly. What you will have to do is what I've written in here. Find f of negative 3. Well, let me erase pretend like you don't see equals 6 there. Kind of ruined the answer. Find f of negative 3. So what you want to do is you want to go, oh, you won't even have that. You'll have this. Find f of negative 3, okay? It's a little bit better. This is what your problem will look like. Okay. So I don't think, in fact, I'm certain you don't have to create a piecewise function. They will give you a piecewise function and ask 3. You can draw this out, but it's a much simpler thing than that. The simpler thing to do is to determine to yourself which category does negative 3 fall into. Is it less than 2? Is it greater than 2? Well, it's less than 2. So you're going to use that rule. You're going to use the first rule. Put a negative 3 in there. You get negative 3 plus 3. That gives you 3. 3 plus 3 equals 6. So the answer there would be 6. So you will not have to create your own, but you will have to determine which group your number falls in and then do that work. Okay. So back down to number 6. We are finding the domain. That's just what are you allowed to put in for x. So we have to factor this out. We're not allowed to allow the denominator to equal 0. X plus 6, x minus 6. So x cannot be 0, x cannot be negative 6, and x cannot be positive 6. I think that that one was done. Let me look at the answers. I think that that one was done with interval notation. The answer set was, yeah, okay. So review you on how to set up interval notation. So let's put our answers in. We got a 0 there, we got a negative 6 there, and we got a 6 there. So those are the no-nos. All of this is good. All of that is good. All of that is good. And all of that is good. Don't include 6. Don't include 0. Don't include negative 6. So let's look at how many segments you've got. You've got this to the left, these two in the middle, and this one on the right. So you've got to describe 4 different areas. So negative infinity going up to negative 6, that takes care of that one. Union with this guy, negative 6 to 0. Union with 0 to 6. Union with 6 on out to infinity. So that's 4 segments because you've got 4 intervals in there. And that's what the answer is. I know you've got another place where you just have to say this. So yay for this one, but sometimes you'll have to write an interval notation. Okay, given the functions f and g, perform the indicated operations. That's f minus g. So we want f, which is 6x minus 4. Then it says minus. And then we want g, and g is 8x minus 9. It's 2 terms. So you have got to put it in parentheses and distribute that negative sign. 6x minus 8x is negative 2x. Negative 4 minus negative 9. That's, if you doctor it here, see, it just depends on how you do it. So 6x minus 4 minus 8x plus 9 would be distributing that negative. So we have 6x minus 8x, negative 4 plus 9. So 2x plus 5 is the answer. I will promise you the answer is also there if you forget to change that. So negative 2x minus 13 will be on there if you're looking at negative 4 and negative 9 and you forget to distribute that negative over there. Okay, for the given functions f and g, find the indicated composition. This is very difficult to read, but what it says is g of f, g composed of f of x. It's a Goff problem. So remember, you start with f of x. So we're going to start with x minus 5 over 7. And we're going to take this and put it into the g function. So in place of the x, I'm going to put this fraction. So the problem becomes 7 times x is x minus 5 over 7 plus 5. The 7's cancel. So we've got x minus 5 plus 5, and those cancel. So you end up with just an x there. Those are, it's just you got to start with f of x. That's the trick. Take f of x with you and move over to g with the f of x function. Okay, matrices. They've thrown in a little matrix problem here. You're looking for the value of the variable, so you know that the corresponding positions match. So the guy in the upper left, x plus 3, will equal the guy in the upper left, 9. So x is 6. There's one of the answers. We've got a y plus 4 equal to negative 3. So y equals negative 7. That's another answer. You've got a z equals 3 there, so you can put 3 equals z, or you're matching. So there are the 3 numbers. I want to see a little bit of work there. I want to see, and I know you can kind of do it in your head, but give me something. Give me something that shows that you have some understanding of that problem. Take you 4 extra seconds to write it down, and you might discover a problem that you might not make a mistake that you would have made otherwise. Okay, let's go to the second sheet. Let's see, let me get attendance here. It doesn't really matter because you can't drop yourself and I can't drop you at this point, but it's one of the things I gotta do. Okay, this is a graphing problem in the Cartesian coordinate system. It's a 2x and y graph. You will not have to show work on any of these graphing problems. I'm not even going to look at them. I'm only concerned about your answer. So on all the graphing ones, no work necessary. You don't have to show me any of your work. Okay, the function square root of x looks like that shoulder, looks something like that. That's not a good version of it, but that's the idea. Then use transformations to graph this, okay? We're going to do the horizontal shift first. So that's a +1 in there. That means we're going 1 to the left. Because remember, it's a liar. Next thing you have to do, let's see, that's HServe. We got horizontal shift, we got shrinking. You won't have to worry about that. We didn't do much shrinking at all. None on your test that covered this area. Next, you want to do reflections, and yet it's reflected. You've got a minus sign, so it is reflected across the x-axis. So we will reflect it down. And then finally, vertical shift, +2. We'll go up 2. So let me take his little neck, and we'll do that. The neck right now is at 0, 0. We'll go 1 to the left, so it's at -1, 0. We'll reflect it down, so it will now look like that. And then it will have to go up 2. So its vertex point is right now at -1, -1, 0. We're going to go up 2 from there. So it'll be right about there, this green, looking something like that. The green is the answer. Okay, find the domain. This is very similar to the previous one that asked you about the domain. When we did this in class, you had to worry about 2 exceptions to the domain. Let's see, the domain is the numbers you're allowed to put in for x. And normally, in most problems, you're allowed to put in any stinking number you want. Your social security number, you can put in your age, you can put in your favorite number, doesn't matter. Pick a number, you can put it in. The only 2 restrictions would be if you have a denominator, that cannot be 0. And then there was a restriction with radicals. If you have a radical, it's got to be 0 or bigger. Your final doesn't have any radical restrictions. So the only restriction on the domain that you have to worry about is making sure that denominator does not become 0. So x plus 7 cannot be 0. X cannot be -7. And I think that that is the answer. It doesn't do it on interval notation. Your multiple choice will just say x cannot be -7. If it did, there's -7. It can be any of that. It can be any of that. It just can't be -7. And so you would be looking for -∞ to -7 union -7 on out to +∞. Okay, this is a graphing problem in the Cartesian coordinate system, so you do not need to show any work on this. I don't need to see even the number 12 written on your paper. I get it that you can do this completely just by looking at the drawing. Let's see, they're asking you for the inverse. You may be able to do this, but this is not my best thing. So let me trace this over so you can see it a little bit better. Okay, and then in order to do the inverse, that's always going to be the mirror image across the diagonal there. But I'm not great at that. I'm not great at picturing it. So in order to find inverses, what I would do is I would take 2 of the points or 3 of the points, whatever suited me, and invert them. So this point right here is -3, 0. That's the regular point. The inverse is literally invert those 2 numbers, 0, -3. So 0, -3 is right there. That's where this is going to start. Let me grab another point. That looks like that goes through the pretty good target there. Let's see, that looks like maybe 2, 3, something like that. 2, 3 is the point, so the inverse is 3, 2. So over 3 up 2, somewhere around in there. Oops, wrong pen, hang on. Maybe something like that. And then if you want to do one more, let me grab something out here. Let's say that that is 10, 3. That can't be right. 1, 2, 10, 4, let's call it. So 4, 10 would be the inverse. Just invert them, swap places. So 4, 10 is up here somewhere. So this is doing that number. That's the inverse. So you're looking for that idea. Some of you can just tell the inverse. You're just better at spatial recognition and that kind of stuff. I'm not. So I would write some points down, invert them, and connect dots. I don't need to see your work for this. I get it that you can look at multiple choice, and I'm good with you just doing it that way. Find the inverse of the one-to-one function. Okay, I'm going to have to use another sheet of paper for that. That's going to be, let's see, this is number 13. We're looking at f of x equals 5 over 7x minus 1. The first step is to turn this to y. If we are looking for the one-to-one, we're looking for the inverse. So inverse is literally, again, swap out the x and the y. So we've got x equals 5 over 7y minus 1. And now the rest of the problem will be spent trying to get y equals. So we want to move everything over here. We want to get it to y equals. First thing you do is get rid of denominators. So I'm going to multiply this side times 7y minus 1 to get rid of that denominator. Whatever you do on one side, you have to do on both sides. So we end up with 7y minus 1 times x equals 5. Okay, still working on getting y by itself. We've swapped them out. Here we had y equals, but we swapped them out, so we're just still working our way through. I'm going to go ahead and distribute this. So we get 7xy minus x equals 5. I'm going to go ahead and put them in alphabetical order. Now, in order to get y by itself, here's y, I'm going to have to get rid of that x, and I'm going to have to get rid of that 7x. So what I want to do is add x first, get rid of the things that are added or subtracted, equals 5 plus x there. And then if I'm trying to get y by itself, and I am, I need to get rid of 7 and x. So divide by 7x there, there, and there. So I get y equals 5 over 7x plus x over 7x, and those x's will cancel. So I get y equals 5 over 7x plus 1 over 7. If there's nothing left on top, you put a 1. And then the last thing you do, the last thing you'll see them doing, is to change this y back to f of x, but it's an inverse. So we're going to do f of negative 1 of x. That indicates the inverse. 5 over 7x plus 1 over 7. And there's the answer that you're looking for in multiple choice. But of course, I'm going to need to see your steps. I'm going to use your pathway, and this pathway needs to lead you to this answer, and it needs to be the one that you pick. You can't just give me crap and expect me to say, oh, you know what you're doing. Okay. Okay, let's look at number 14. Find the zeros for the polynomial function and give the multiplicity for each zero. State whether the graph crosses the x-axis or touches the x-axis and turns around at each zero. Okay, so you're looking for variables here. We've got an x plus 5 and we've got an x minus 5. So this zero right here is made up of, the zero is negative 5. Remember that it's always a liar when it sits by x. So that says x plus 5. So the first zero is negative 5. It has a multiplicity That means what is its exponent? Its exponent is a 1. So it has a multiplicity of 1. And then because it has a multiplicity of 1, it's going to go screaming through the x-axis. So it will cross the x-axis. The other variable is attached to a -5. That means its 0 is a +5. It has a multiplicity of 2, because there's an exponent of 2 right there. And that means that it's going to touch the x-axis and turn around. So it will touch and turn. For instance, what it says is that here at -5, it's going to, let's see, was it going to be positive? Yeah, so it's going to come up here. And then at 5, it's going to do something like that. It's going to touch and turn at 5. It's going to cross the x-axis at -5 because it has a multiplicity of 1. It was some of the funner things we did there. That section got intense. That was test 2. Oh, and by the way, if you're looking at the review on the Google slide, beside each one of these problems, there's a little number out here. That's a section number for where you can find problems like that. You can go to your notes. You can go to my math lab, whatever. Okay, use the rational zero theorem to list all the possible rational zeros for the given function. Okay, so remember that the way to get all the rational zeros there, all the possible numbers that might go in there, is you're looking at the leading coefficient of the back divided by the leading coefficient of the front. So we're looking at all of the numbers that divide into 12. That'll be a plus or minus 1, plus or minus 2, 3, 4, 6, and 12, divided by all of the numbers that divide, or all of the factors of 1, all of the numbers that go into the coefficient of the first coefficient. So dividing all these by 1 wouldn't change anything, and that's the set of answers. Let's do that again on number 16. Here we're looking for a rational zero. Let's first find all the possibles. So all the possible numbers will be everything that divides into 6. So that's 1, 2, 3, and 6, divided by, here's the denominator, 4, plus or minus 1, 2, and 4. So all the possibles, remember we're starting here, we're going to take each of these numbers and divide them by 1. So plus or minus 1, 2 divided by 1 will give you 2, 3 divided by 1, 6 divided by 1. Now let's go through and divide everybody by 2. So plus or minus 1/2. 2 divided by 2, we've already got it. 3 divided by 2. 6 divided by 2, we've already got it. Now let's go through and divide everybody by 4. Plus or minus 1/4. 2/4 is 1/2, and we've already got it. 3/4. And then 6/4 is 3/2, and we've already got it. So these are the possibles. We're not going to mess with those when we start dividing. We'll have those happen to us by factoring. But let's concentrate on these whole numbers here. So we're going to do this the fun way. So let me look at number 16. Let's see, 16. Let's look at the coefficients. We've got 4, -19, 19, and 6. And let's start with 1. Let's just see what we can do about dividing synthetic division by 1. Bring down the 4. 1 times 4 is 4. That will give us a -15. 1 times -15 gives us a 4. 1 times 4 is 4. Remember, you're looking for a 0 here. That did not work, so 1 is not a good one. Let's try -1. Again, synthetic division, -4, -23, 23. Ooh, this is getting crazy fast, isn't it? 42, that's not going to happen. So -1 is no good. Let's look at a +2 first. We've got 8, -11, -22. That gives us -3. That gives us -6. Yay, that gives us a 0 there. So we have found one of the zeros by synthetic division. Let's go find the other. So let me go back to this problem right here. It's looking for find a rational zero and use it to find all the zeros. We just found out that 2 is a zero, so I'm going to put 2 right there. I don't want to lose him, so I know 2 works. And then what I've got left over, remember this was 4x to the third, so this will be 4x squared, and then just march your way down. Let's solve this bit. Putting 2's here is not going to help us. It's not going to get us to 11. So I'm going to put 4x and x. The signs need to be different. I'm going to put them like that because I want to show you, this is not going to work, but I want to show you how to repair in case that happens. 3 is 3 times 1, so I'm going to put a 3 there. Look, that gives me 12. Good. That's very close to 1 and 1. So let's see what we've got here. We have a positive 12x on the outside. We have a negative 1x there. That gives us a positive 11x. We wanted a negative 11x. So the numbers are right. Leave the numbers alone when the numbers work. If the sign is wrong, just change the sign. That becomes a plus. That becomes a minus. And now let's set each of these equal to 0 and solve. So x equals 3, x equals negative 1/4. And sure enough, I want you to know that 3 is on our list and negative 1/4 is on our list of possibles. So all these others are wrong. Only a positive 2, a positive 3, and a negative 1/4 are the answers, but they are in our list of possibles. So negative 1/4 and 3, those are our 3 answers. Okay, number 17. The answer on this is weird. I think this is a bummed review. I got it from another teacher who's just a wonderful teacher, but I think there's a little problem with the answer here. This is 3 questions. Does the graph represent a relation? Was 2 an answer? Yes, 2 is an answer in that last one because we found it. It's one of the zeros. We found it by using synthetic division. You would expect 3 answers because the exponents are 3, and there are 3 answers. Is that good, Rebecca, or is there another question about it? Okay. Anybody else? Okay. I almost asked you earlier, Ashish, when I can't remember what it was, but I almost asked you if that meant nobody had any problems. Okay, this number 17, this is actually, I believe, 3 questions, or should be, and I've looked at the final, and so that would be helpful to you if it were 3 answers. Let's go through it. Does this graph represent a relation? Let's take that as the first one. A relation is any set of paired numbers. So yeah, this is a relation. It's just a bunch of xy's. Is it a function? Remember, the function has to pass the vertical line test. X cannot repeat. A vertical line test, VLT. Vertical line test, this is going to pass it. Any line I drop down that's vertical will only cross through this once, so it is a function. Is it a function that is a one-to-one? In order to be one-to-one, you have to pass a horizontal line test. And if I run a horizontal line test, ding, ding is good, ding, ding is not good. So this does not pass a horizontal line test. It is not a one-to-one function. Now, why does a one-to-one function matter to us? It matters because you can only find the inverse of a one-to-one function. Let's go back to where we found the inverse, number 13. Find the inverse of the one-to-one function. They assure you it is a one-to-one function, therefore you can find the inverse. So in order to be able to find the inverse, you have to be a one-to-one. You have to pass the horizontal line test. So look what I've written here after looking at the final. I've written has to be a one-to-one in order to find an inverse for it. So this function has to be a one-to-one, has to pass the horizontal line test in order to find an inverse. So if the question were, can we find an inverse? This would be a big fat no. We cannot find an inverse because it is not a one-to-one function. because it flunks the horizontal line test. That's the measure. Okay. Number 18, find an nth degree polynomial function with real coefficients satisfying the given conditions. Absolutely, I'm going to look at your scratch to make sure that you know what you're doing on this one. 100% you can be guaranteed that I will look at that. So let's look at it together. Let's see, on this one, number 18, they tell you that n equals 3. They tell you that -6 and I are zeros. And they tell you that f of -3 equals 60. Okay, that's probably one of the ones that's sort of buried somewhere in your brain that you may have forgotten how to do. F of x equals a times, I'm going to put an a there, that's going to help us solve this piece of it. Right now we're going to work on the parentheses though. We're told that we have 3 different variables here, so we set up 3 sets of parentheses. These will all be x's, and they'll all be minuses. -6 goes in here, and of course that's going to turn into x plus 6. We're told that I is a 0, so we're going to put in x minus I. And you have to know that if any imaginary number is included in there, his opposite is also included there. So x minus -I, which turns into x plus I. Remember doing that? It's been a while, and it was, kind of different. I'm going to go ahead and FOIL these before I throw that one in, because foiling these two is going to be easier. So f of x equals a times x plus 6. Foiling this out, first is x squared. Outside is a positive I, x, ix. Inside is a negative ix. Those go away. These are conjugate pairs. Always the outside inside cancels out. Then we've got a negative I squared. I squared is a -1. So out of this, we're getting x squared plus 1. That's a minus a -1. Okay, let's leave the a there still. Let's FOIL this piece out now. And when we do that, I want to get them in the right order. So I'm looking for descending order. X times x squared will give me my highest order. Now I'm looking for what will give me the x squared piece, and that's 6 times x squared. If you can't do that, do them in whatever order you can do them in, and then get them in the right order. Next, I'm looking for the x piece, and that x piece is going to be x times 1, so plus x. And then finally, I'm looking for the number piece, plus 6. Okay, now is the time to use this f of -3 equals 60. So I know that if I put a -3 in for the x's, I'm going to get a 60 right there. -3 cubed, 6 times -3 squared, -3. Okay, so 60 equals a times -3 squared is -27. This is 6 times a positive 9. This is -3 and positive 6. So I've got 27, 24 plus 6 is 30. So I'm trying to solve for a, divide by 30. We get a equals 2. So take that 2 and plug him up right in here. Put a 2 right there and distribute it. F of x equals 2x to the 3rd power plus 12x squared plus 2x plus 12. There you go. So it's a pretty routine thing. You've got 3 different examples on the final review to go over it. Use your notes for the first couple, then stop using your notes and do a couple where you don't use your notes. That'll be falling off a log easy for you if you need to get remembered back in that stuff. This is not difficult. The math is not difficult. It's just a pattern. Okay. Oh, that's what I was going to ask. Ashish, is everybody done looking at number 18? I was going to ask you that on a previous sheet. Okay, good deal. If you're not with Ashish, sorry, if you are not with Ashish, just let me know and I'll show it to you some more. Okay, number 19, solve the problem. You've got solve this equation, 2x cubed, blah, 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 given that 4 is a 0. So we've got a problem where they're giving you one of the zeros. We're going to have to find 3 of them, and they're giving you 1. So this is going to be very similar to the previous page where, number 16, where you had to come up with the zeros and you had to find your own. Here they're giving it to you. So let's see. Number 19. We got 2x cubed minus 17x squared plus 31x plus 20, and they're telling me that 4 is a 0. So I'm going to put 4 there and find out what I've got left over to factor. They tell you that 4 is a 0, 4 is a 0, and they're giving you this. So let's do synthetic division. 8, negative 9, negative 36. So we get negative 5. 4 times negative 5 is negative 20. You knew that was going to happen because they told you it would. So this was 2x to the third power. This will be 2x squared minus 9x minus 5 equals 0. 2x and x. Signs need to be different. 5 is only 5 times 1. I'm going to get a negative 10x out of the back there, and the inside is a plus 1x. It's negative 9x. Good. That's what I was looking for the middle term. So this is correctly factored. So x equals 5. And then on this side, move the 1 over. It becomes a negative 1, and divide by 2. So there are 2 of our answers. Here's our third one. So the 3 zeros there will be 4, negative 1/2, and 5. All 3 of those numbers, this one that they gave us, and these 2. They may ask you just for the other 2. I don't know. You can handle that. So it would be these 2 answers. Okay, here's another graphing problem. So I do not expect to see any scratch work on these. If you've got scratch work, if you need to show scratch work, you do you, that's fine. More is better. But on, like I said, on all of the graphing Cartesian coordinate problems, that's an x-axis and a y-axis, I don't need to see any work. Okay, this is an x squared. That means it's going to be a parabola. And it's negative, so that means it's going to be going down. So that pretty much limits us right there. That's all you got to worry about. Falling to the left, falling to the right. You know, it's the only one that qualifies here. You've got to know what an x squared graph looks like, and you've got to know what happens when it's a negative. Fairly simple problem there. Let's see. Let's look at number 21. Again, find the domain. This is the third problem that has specifically asked you to find the domain. That cannot equal 0. So let's set it up to equal 0. Cannot equal 0. Factor out an x. Cannot equal 0. This is not factorable. Be careful. You end up with x minus 25, not x squared minus 25. We're done. X cannot equal 0, and x cannot equal 25. And that's it. Okay, then we got into some pretty difficult stretches. Yours are not going to be difficult. I've looked at the test. I know what you need to know. Let's go through this set of problems. 22, 23, 24, and 25 dealt with those more difficult, complicated graphs. Vertical asymptote. Find the vertical asymptote. Remember, a vertical asymptote would be a line that is vertical about which your graph would not be able to pass. It looked like that and that kind of thing. Could not cross over that wall. That's what you find when you set this equal to 0. So x squared minus 4 equals 0. Let's factor that. X plus 2, x minus 2. So x equals -2 and x equals 2. Those are the vertical asymptotes. You just got to set the denominator equal to 0 to find those. That's all you've got to do. Horizontal asymptote, that's a different story. That's a trickier thing to do. I've written the 3 rules here. I would commit those to memory somehow. I mean, this is such an easy problem, but you've got to memorize those 3 steps. If the numerator's degree, if the top degree is less than the bottom degree, then y equals 0 is the horizontal asymptote. Okay, let's look at our degrees. Our degrees are equal here. But if it had been like 9x on top and 3x squared on bottom, where the top degree is less than the bottom degree, then the horizontal asymptote would be y equals 0. If the top degree were bigger than the bottom degree, there would not be a horizontal asymptote. For instance, 9x squared over 3x, the top degree is greater than the bottom degree, there would be no horizontal asymptote. And then finally, this situation where the top degree, the 9, is equal, sorry, I don't know what I'm thinking, getting ahead of myself. The degree, second degree, is equal to the second degree on bottom. The exponents are equal to each other. Then to find the horizontal asymptote, you do the leading coefficient of the top, that's 9, divided by the leading coefficient of the bottom. That's what it is. So we've got this equality of exponents. So we're going to do y equals 9 over 3, which is 3. So y equals 3 is the horizontal asymptote for the problem. Okay, we have 2 transformation problems that you have to worry about, and they're fairly basic. Remember what we did when we were in class where, we went through and had to come up with all kinds of points on this side and that side and all that? That's not going to be the level of difficulty for your exam. You need to know that basically with the 1 over x, you got stuff happening there and you got stuff happening there. That's what a 1 over x looks like. Graph of y, f of x equals 1 over x. Is stuff happening in the first quadrant, a boomerang in the first quadrant, a boomerang in the third quadrant. Now the transformation for that is only involving +2. You need to know if that's on the horizontal or if that's on the vertical. If it were on the horizontal, it'd be down here in the denominator, like 1 over x plus 2. So it's not, it's out here on its own, so it's a y change, it's a vertical change. We're going to go up 2. So we're going to take these that are sitting here doing, they go through 1, 1, and -1, -1. So they're doing something like this naturally before the transformation, they're doing something like that. After the transformation, you want to lift them up 2. So take that belly button and move it up 2. We've got that sort of thing. Move this belly button 2. Oops, sorry. No, that can survive that. And it does that, not that piece though. So it's just this boomerang moved up 2, this black boomerang moved up 2. And your graph choices will be so drastically different that, it's going to be easy to spot it. They're going to be easy, like this set of graphs was easy to pick from. They didn't give you one that was just a little bit skinnier than that or a little bit fatter than that. I mean, it's just really obvious if you know what you're doing, you can pick the right one. Same thing here. If you know what the boomerangs look like, where they are in the first and third quadrants, and then lift them up 2, you're good to go. It's something on my brain about that. Oh, 1 over x squared, that's where you just move this guy up to the top. It would be in the first and second quadrants, but you're not going to have a 1 over x squared on your final exam. This practice is very good practice for the actual test. Okay, this is one of those that look like hell on earth, I thought. I'm not a fan of all that graphing that gets into the details. You're not going to have to worry about that here. What you do have to worry about are vertical asymptotes. Remember, that's setting the denominator equal to 0. Let's do that. Equals 0, so x equals 3. So, and down. There's our vertical asymptote. Horizontal asymptote, you have to worry about that. Let's look and see. We've got x to the first over x to the first. So the degrees are equal to each other. So we're looking at y equals the leading coefficient of the top over the leading coefficient of the bottom. So y equals 2 will be our horizontal asymptote. So running through here. Okay. There are no x squareds here, so we know they're going to be boomerangs, and you're done. Something like that. Just make sure you got something in the first and third. This should definitely be scooted up. That should not be there. Let me do it in green. It'll be doing something more like that, but it's okay. It's still a boomerang in the third quadrant. So that's all you have to worry about is you've got 2 questions, one on a basic boomerang and one on a little bit messier where you have to worry about horizontal and vertical asymptotes. You need to know where those are. They could scoot them anywhere. So you've got to know that the vertical asymptote is the denominator set equal to 0. You have to know the rules for horizontal asymptote. So that's 2 problems where they're asking you directly to come up with the horizontal asymptote. Okay, and then the last problem we're doing today, I do need to see work on this because this is not a graphing on 2 axes. This is a number line one, so I expect to see some work on this. So we've got x squared minus 2x minus 3 is less than or equal to 0. You're going to need to show the factoring there, x and x. Signs need to be different. I need 2 numbers that multiply to give me 3, whose difference is 2. That'll be 1 and 3. If I want to get a negative 2 out of that, I need a negative 3 and a positive 1. So my 2 goalposts are at negative 1 and a positive 3. So I got this guy right here, and I got 3 right there. Okay. This says less than or equal to. That means that we're going to be able to include negative 1 and 3, so we're going to have brackets. And because this is pointing inside, we want to go and shade inside those 2 numbers. So we're going to be shading inside the 2 numbers because it says less than. That always points you inside. If it said greater than, we'd be using these guys out here on the outer sides. And it says equal to, so we get to use brackets. So the answer then is negative 1 to 3 using brackets. Okay, that is number 26. We are done. I want to remind you that if you do not number your problems on the final, the 40 problems on the final, if you do not number them, I'm going to take 10 points off. So be sure and number them for me, please. Show work on every problem that you think there is any little bit of work that needs to be shown, like show your factoring. All graphs do not need to show work. No graph needs to show work. There's going to be very little work shown here. It would not kill you to write y equals 9 over 3 equals 3. It wouldn't kill you, but I'm probably not going to be checking this one because there's so little work to show. If you're, any doubt, like factoring problem, I want to see your work. Factoring problem, I want to see your work. If you're in doubt of whether I need to see the work or not, show the work. If it's that little work that you know that you're wondering, do I think you can do it in your head, then it's not going to take you very long to write it at all. So, okay, I think I'm done. Let me stop recording this.